this curve at this point, you can write an expression for the slope of the curve at that point, or you can write a slope of the curve at any point using this. Okay? If we want to write it at that point itself, slope of tangent limit as h approaches 0. So you have two parts to your function here. You have h there. Oops, I should move this. On the top of this thing here we have f of x plus h minus f of x. You can write it with x's and then substitute the number in after. You can put the number in at the beginning if you want. Our function is actually, what is our function here instead of this function? What's our function there? X squared, right? So we can write the expression for that. You could write x plus h squared minus x squared over h. Or if you wanted to, since all you want to know is a specific point, you could write it with that value substituted in. If all you want is a specific point, you can work it out with the value in there. You can write it as the x value is 2. You could say 2 plus h squared minus 2 squared over h. And then you can work it out. You'll get an actual expression. We can maybe do both here so we see the difference. Oops. What can we do with that now? So this is general for x. This is specific for 2, right? If you want to try and work out this limit, why can't we just sub this in right away? Why not? Because you get a really big number. Because you get we can't actually evaluate it at this point with h there. Because you don't know actually. If it's not a 1 or a constant on the top or the bottom, it's hard to tell. Is it a big number? Is it a small number? Is it somewhere in the middle? It depends. But you can simplify this stuff and work it out. So let's try and do both of these in parallel here, the specific one and the general one. If you're going to evaluate this, you need to multiply this out. X squared plus 2xh plus h squared. I'm going to assume that we're okay with that at this point, and we don't even actually need those brackets. Have we finally mastered the grade 9 art of squaring a binomial without having to write all 4 terms and then combine the middle two? We're not quite there yet. Takes time to perfect something, I know that. You didn't learn that binomial theorem in grade 12 math and actually take it to heart. You just learned it as we do this now. We don't actually ever use it when we're to save ourselves time. Okay. Anyways, if you do that, then of course you can start to simplify this thing here. 2x squareds cancel out. You get 2xh plus h squared over h. Or in other words, still not evaluating the limit, must still write this. No, it's painful for some of us. 2x plus h over, we got rid of our h. Divided that, right? Probably it's a good idea to put some brackets there. Okay, now can we put this in? Or not, can we put the 0 in? You can put the 0 in now, right? So you get 2x plus 0. So you get 2x. Okay? Doesn't seem like a number yet, does it? If you did the one over here, you'd get exactly the same thing, but you'd get the actual number. So in this case, I could just take the x value, right, that I'm given. If x equals 2, then what's the slope? Slope is 4, okay? Or you can, the specific expression for the slope at that point. Like the nice thing about what we just did is you can evaluate this for any value you want to put in there. The specific ones, sometimes the algebra might be easier. You might get hung up on some algebra when you write a general expression. But I mean, you could try either way. If you work this one down, you get, we'll try to do this one really quickly here. I mean, it's exactly the same as this, except for everywhere there's an x, it's a 2, right? 4 plus 4h plus h squared minus 4 over h. 4h plus h squared over h. Don't forget to write limit as h approaches 0. Four plus h. Okay, it's exactly the same thing. You put this in, you get 4 plus 0, or 4, right? This is specific to when x is 2, right? You did a whole lot of work and all you have is one value. If someone says, now go and do it for when x is 3, you got to go and do that whole thing again. So where we're going with this is, a lot of times what we're going to do is come up with a general expression for the slope of the tangent line. Okay? So this thing here is a general expression for slope of the tangent line. I mean, this tells you the tangent at any point you want, right? You want to know the slope at -2, it's -4. You want to know the slope at 10, it's 20. You can come up with a slope anywhere just by having done this once. Okay? Does that make sense? All right. I'm going to stop this and start again. Not start again, but restart the video. Okay, that's a pretty important thing to understand. So make sure you understand the steps in that and not just kind of memorizing and everything.